We learned that there has been a progression of scientists' understanding of the structure of an atom. In this video, let's focus on one, Bohr's model of an atom. You're probably familiar with this image. You can see that the positively charged nucleus is surrounded by the negatively charged electrons. The electrons cruise around the nucleus, minding their own business, content to keep circling in their home level until something happens to change their mood. The curious chemistry student heats up an atom using a flame or maybe a laser beam. The once content electrons get excited. The sudden burst of energy is like chugging a Red Bull for the electron, and they jump energy levels. That jump takes a lot of effort though, and soon they fall back to their home levels. When they fall back down, the electrons release a little bit of energy. But Mr. Condit, what does this released energy look like? Great question. This energy takes the form of light, more specifically a photon, and depending on the organization of the electrons, the light release changes colors. As scientists, we can use this qualitative observation to identify atoms, since each atom has a unique electronic arrangement. If we test a known substance, say copper, and when we heat it up it turns blue, then we can take an unknown substance and heat that up. If the flame turns blue again, there's a good chance its electronic arrangement is identical to copper. So, let's review. When a substance is heated in a flame, the substance's electrons absorb energy from the flame. This absorbed energy allows the electrons to be promoted to excited energy levels. From these excited energy levels, the electrons naturally want to make a transition, or relax, back down to the ground state. When an electron makes a transition from a higher energy level to a lower energy level, a particle of light called a photon is emitted. A photon is commonly represented by a squiggly line. The energy of each emitted photon is equal to the difference in energy between the excited state and the state to which the electron relaxes. The energy of the emitted photon determines the color of the light observed by the flame. The color of light observed when a substance is heated in a flame varies from substance to substance because each element has a different electronic configuration. The electronic transmissions for a given substance are unique. The color observed when a substance is heated in a flame can be used as a means of identification.
Created using Powtoon.